Hey Kayla, how are we doing today? My hair is going crazy. How you doing? I'm 15 minutes early, but I need help with assignment 9, 1 and 2. If there's time about other questions, I'd like to look at 2C as well. Thanks in advance. I hope you're doing well. Thank you so much. Yeah, I know. I'm going to get a haircut. The hair is just getting pretty long right here. So let's get in my face right here. And yeah, the big day is on Saturday. Number 2 and number 3. Which one should we do here, Kayla? Let me know. Put on a little music right here. And if you let me know which one we should do, we'll start doing that. We'll get this ready right here. I'm getting some stuff pulled up. A lot going on right here. But which ones should we do? Which one should we do? Let's see. Getting everything ready. We got the assignment. E2 and E3 for sure, which I'm stuck on the drop 1. Good stuff with the drop 1. We'll be talking about that today in class. Let's go look at that first example of drop 1 right here. Let's talk about the drop 1. Oh, did I lose the assignment? What? Let's close everything out. How did I lose the assignment? 2 seconds here, Kayla. Lost the assignment. Lost the assignment. Assignment 9, right? Found it. The drop 1 is a pretty fun and interesting command right here. So let's pull up the first instance of the drop 1 right here. Oop, E2. Okay. Oh, and E1. So yeah, let's do E1 and E2. Oh, and E2. Let's start with E1. We'll do E1. The ease of this. So let's take a note here in the chat. 5 minutes, 45 seconds in. BAS 320. And we are doing assignment 9. We have a question from Leo. Leo, I think, asked it. And E1 through 3. Okay, let's take a look. Here we go. Okay. Fit a model predicting demand from using all the predictors. You can use the tilde, and we've got the data loaded up. Make sure to load everything previously and load up all your data. We see homework 9 bike in here. Leo, yes. Oh, you bet, Leo. We'll do it next here. Thank you so much, Leo. There we go. I said, oh, we got this. We'll do that here next. You got it. And so we're going to fit a model predicting demand from all the predictors. We do y tilde x comma data equals. And here we go. Homework 9 bike. And so now let's take a look at the summary. So when we look at this right here, these are all the variables in the model. Does this output make sense to you, Kayla? Do you understand every bit of this? Tell me if you don't understand anything in this output right now, which I think we basically have it all on the screen. How's everything look? Ubot saying hello in the chat to everybody. How does all this look right here? We have the variables in the model, which are like day of the week. We have working day, holiday, weather, humidity, temp, and wind speed. Some of these are categorical variables, hence the indicator variables like humidity low, humidity moderate, temp is quantitative, wind speed is quantitative. Working day is a categorical variable, and it's compared to working day no, and we're predicting the demand of bikes. These are the misses that the model makes right here. We have the R squared, which is the percent of variation explained. The only thing I don't understand is the coefficient next to the intercept, also the value of the reference. Are you talking about which? Can you type the number, Caleb, you're wondering about? Are you wondering about this right here, this right here? You're saying the coefficient next to the intercept. Are you talking about the coefficient right here? So that would be, or like, so that is the intercept of the model right there. And the intercept of the model would be the predicted value for a temperature of 0, wind speed of 0, or the average prediction for temp of 0, wind speed of 0 for a high humidity day, no rain day, holiday no, working day no, and the day is Friday. So the average, it's a lot to say. I wouldn't have someone interpret that, but the intercept is the value of the prediction we would have for on average for a Friday, because that's the reference level, for a non-working day, because that's the reference level, for a non-holiday, because that's the reference level, for a non-rainy day, for a high humidity, because that's the reference level, and for a temp equal to 0. Now, why did I switch my language to temp equal to 0? Think about why I just changed instead of saying, so it's the prediction for that. And why did I change to say temp equal to 0? So why did I then change that to say temp equal to 0? Because temp is a what variable? Compared to the other ones, which all have like day Monday, or weather rain. Well, not because there's one level. Good answers. Not because there's one level. Temp is a what variable? It's quant. It's quantitative. So temp and wind speed are both quantitative variables right here. Those are quantitative, where the other variables like day, working day, that's why they have the appended indicator variable on them. The variable itself is working day. Just doesn't show the variables there, but the variable is working day, and then the level is yes. So the reference we're comparing it to is no. So that's why if it's not a working day, yes, it's working day, no. If it's not any of these days right here, we'd set them all to 0. It's Friday. So I don't have to say it's not Monday. So the intercept is Friday, working day, no rain, high humidity, and what's the last thing? Add on a little appended on there. Make sure to speak. You got this. And the intercept is also the predicted value. So I'll read off here. Put the last little bits I've highlighted there. The intercept is the predicted value that we would expect on average to see for a Friday that is not a working day. There's no rain, there's high humidity, and the temp and wind speed are 0. That's the average predicted value, which probably is an extrapolation of the model, because a temp of 0, this is Celsius, is probably unlikely. Then yes, Kayla, 500 points, great job. We should know what the output means. And the intercept is the predicted value when all the x's are equal to 0. X is equal to 0 means it's none of the indicators, and the quantitative values would be equal to 0. And that's the expected value. And then knowing what these are right here, like the expected difference between a Monday and a Friday, everything else equal, is this, where the Monday is expected to have 364 less demand. Very important we understand what's going on with this output. Like, what do these all mean? These are the uncertainties. These are the t's, which leads to the p-values, all this good stuff. Now that we know what this output means, let's look at some of the questions. And if you ever have questions on the output, please let us know, because it just builds. Like, once you understand that output, it's pretty quick. There are all differences between that particular one and the reference of that group. Like this right here is the difference between Sunday and Friday. So Sunday's demand, all else equal, is expected to have less demand than Friday by 398, where one day is a Sunday and one day is a Friday. The demand on Sundays are expected to be 398 less. Great job. After accounting for all the information available, and if the day was which day of the week has the highest average demand and which day of the week has the lowest? Note these answers are found by looking at the coefficients exactly. So how would we find out which day of the week had the highest demand right here? Ooh, it's a good tricky question. I love it. I love it. How would we figure out? And there's an issue. I think you got it correct, Kayla. And so, but I don't see Friday. And there's if Friday had a coefficient, if we were to give it a value, what is the coefficient of Friday for its impact on the intercept? Of course, ask away, Ashton, you bet. Definitely. If Friday had a coefficient, Kayla, what would the coefficient of Friday be? And it doesn't have one, which is the answer to what its coefficient would be. But if Friday had a coefficient, what would the coefficient of Friday be? And then you can compare and see why Friday is the highest. 0. So then why is Friday the highest? And just talk to me theoretically. All other numbers are what? Because that's their comparison to Friday. And Friday theoretically could be said to have a coefficient of 0. And you just put one symbol in the chat because they're all negative. So Friday is the highest. So these negative coefficients tell us that compared to Friday, all else being equal, the day that is on whatever other day of the week is expected to be lower. Great job, Kayla. That's a great learning objective, and that's why this one's a little bit trickier. You don't see the highest. Sunday is super duper negative. You got there right there, 100 points. And Monday is very similar to Sunday too. We can't visualize this model, and we'd see the lines a little bit closer. And Ashton, feel free to ask the question. We'll take a look. Love test questions. So I think that's got it right there. After accounting for all the other information, is there a statistically significant difference in demands between days? You'll need to drop 1. So the reason we don't know if day is statistically significant is because day, and think day has 7 days of the week, day brings with it how many indicators. If it's 7 days of the week, day creates how many indicators. So if day has 7 days of the week, day brings with it how many indicators? So day brings with it how many indicators? I'll show you the long way and the easy way of doing this. Brings with it 6 indicators, exactly, because 1 becomes the reference level and the 6 remaining ones are indicators. Friday's not seen because it's the reference level. Exactly, Kayla. All-star right there. Great work. And just practicing, following along. That's the way to do it and get it down. One of the questions was about a roller coaster. We had to interpret the y-intercept with speed. If time was 0, then with the roller coaster speed. Good question, Ashton. I can take a look. If you want me to look at how yours was graded and see if I agree with the grading. And that kind of goes to, funny enough, Ashton, that's such a great question because we were just interpreting the intercept. So this kind of goes to, so 320, if you're watching, we could bring up a kind of, we're doing some models over here in 475. As you see, predictive models are used throughout all of our classes. So such a great question, Ashton, to kind of throw in here for 320 to see if they're watching this video later. If you have a model predicting speed of the roller coaster, and it is equal to something like -20 plus, and let's say 0.3, and speeds in miles per hour, and then minutes. So let's think about how this would be interpreted right here. And this goes. Now, in 320, we go a little more in depth in our interpretation. So in 320, the interpretation of the coefficient of the slope would be at 2 points in this roller coaster, because the roller coaster might have some sort of thing like this. It might not actually be well described by a linear model. It might do something like that, and then it'll probably go back down. But if the linear model is going through it, it might be something like that. That might, if you notice, the model doesn't accurately predict the start of the roller coaster. But the 320 interpretation of the slope would be at 2 points in the roller coaster that differ by 1 minute. The point in the roller coaster that is 1 more minute into the ride would be expected to be 0.3 miles per hour faster. The 201 interpretation, which has some issues, and this is a little more cause and effect, so it might make a little more sense because time increasing throughout roller coaster ride would increase speed. It's how roller coasters work. If you're on it longer and it's going downhill, you're going to speed up. But the 201 interpretation, which we don't use in 320, would be for each 1 unit increase in the minutes of the ride, we'd expect the roller coaster to increase by 0.3 miles per hour. Little cause and effect. That's why I don't like in 320 when we go into like the business analytics interpretations. But the intercept interpretation stays pretty consistent in 320. What is the intercept interpretation of this? Now remember, speed, and this is good 320 practice. Speed of roller coaster is in miles per hour, and this will be in seconds. I said minutes a moment ago. It wouldn't matter. Rock knows.
It doesn't matter.
Because we're basically doing what right here? So how would this be interpreted? And then we should probably mention something to somebody here. So how would this be interpreted to a reader? So Kayla, this is good practice too. What is the intercept? And the value of the intercept is down here right now, visually speaking. The value of the intercept is down there, and that's what we're interpreting. So what would be the interpretation of this? And Ashton, I can take a look here when we go back to the main screen, take a look at grades, see if I agree with the grading and how it was graded, but how would that be interpreted as a value? So what would we say about this? How would we explain to somebody? When time is at 0, we expect the speed to be at -20. Boom, Kayla. Just great job, Kayla, right there. Great practice. We're throwing another 500 points, Kayla. Great job. And then we might, don't worry, like the only thing I would say, which you obviously said it's illogical, is you might say like you can't have negative speed of a roller coaster. I know what you mean by illogical, and I'm glad you added that on there. But when the time is equal to 0, when there is no time on the roller coaster, that the roller coaster hasn't started, we'd expect the speed to be -20. This is illogical because the roller coaster can't have negative speed. It can have time equal to 0. When there is no time on the roller coaster, when 0 minutes have elapsed or 0 seconds, then the roller coaster is expected to be at a speed of -20 or predicted on average. Good things right there. Do you want me to take a look at that, Ashton, see how it was graded? Because it's subjective, unfortunately, on how the grader looks at it. And sure, Ashton, give me a moment and I'll take a look at it right after this. I go to the main screen when I do it, so just so I'm not like showing grades, but I'll take a look and I'll tell you I looked at it. I'm not gonna say any grade changes or anything on here, but are you cool with that? Yes or no? I'll tell you I look at it. I can look at it later if you want to, if you send me an email, but I can look at it now. This is office hours. You got it? Cool, 100 points, Ashton. We'll take a look. I'll see if I agree with the grading. I'll say I looked at it. Won't say any grade changes or anything on the stream, but I'll tell you I looked at it. Awesome work. Thank you, Ashton. And good practice, because that's what we're doing right here with predictive modeling in 320. It's the same concepts we build upon. So what we're going to do right here, Kayla, is we don't just have one variable for this roller coaster. We have a lot of things. Like, just think about it as a roller coaster. Like, the roller coaster has a whole bunch of things explaining how fast it goes. How fast it goes is demand. That might as well be speed of the roller coaster is explained by all these things. So now, is John? Oh, yeah, that's going to really help, Ashton. Thank you so much. Oh, yeah, thank you so much. That'll help. If I'll be like, I'm fucking fond. Yeah, I'll take a look. That's awesome. Thank you. 100 points again. And so now, when you look at the impact of day in the model, what could we do here theoretically to see, just think theoretically, Kayla, what you would do to look at a model with day and without day. What would you have to do to look at a model without day? You'd have to do what to those 6 things right there? What would you have to do to look at a model with day and a model without day? What would you have to do to look at a model? Get rid of all 6 of those, right? So you can do this the hard way. We'll do it the easy way in a moment. Where you can go subtract day. This is the hard way. I would not suggest this. So now this model here, if you take a look at it, it doesn't have day in it. Does that make sense? And the reason we have a partial f-test, now down here is the f-test. This compares our model to a model with nothing in it. The f-test compares our model to the what model, Kayla? If we talk about an f-test, the f-test says here's our model, and we're going to compare it if we do an f-test to the what model. Think of a model with nothing in it. No variables, no x's, nothing. It knows nothing. It's what to the world. So the f-test, the naive model, the naive, got the extra, don't worry. I thought you did it, and I was like, the naive model. So when you think about a partial f-test is called this for a reason, because a partial f compares our model to a water model. So it's got stuff in it. The partial f is going to compare our model, oh, and you're fine, to a model that is water. So a partial f doesn't go the full way. Think of why that's just called the f-test, and this is called a partial f. It's comparing it to a smaller model. Does that make sense? So with fewer, exactly, it has fewer x's. And look what we've just done right here, is we have this model here, and we have this model. So this, fewer, this, bigger. So we go here, and we say, should we go from the small model to the big model? And the answer is no. Now, that was a big thing to do. So the question is, going from the small model to the big model, is there a significant reduction in the sums of squared error? The null hypothesis is that there is not a significant reduction. So we do not see a statistically significant reduction. This just means we shouldn't include day. Like, to put it in classic understanding or just basic terms, day doesn't help us. But there's got to be a better way. And if you look at that value right there, drop 1. You remember that value? There it is right there. Drop 1. Just think what the code is named and what it does to each of our things in the model. It does what? What does drop 1 do? And it does it algorithmically for each one. So it does multiple partial f-tests. What do you think drop 1 does? The reason why it's called drop 1 from your model, it's looking at the what? Like, how would you explain that to be like, what does the drop 1 code do again? It's going to do repeated partial f-tests where it's looking at and dropping. What do you think it does? Don't worry, I can always answer questions. I know you might have like, they drop 1. It looks at each one. It goes through each one and drops each one out of the model. So it just ran 7 partial f-tests. And if you look at the p-value right here for working day, do you see this p-value? That p-value for working day is the same p-value here. The p-value will be the same if we're just dropping one thing that has one level. Do you see how like this is 1.875? And you see how that's rounded, it's still 1.75. But we don't need to use the drop 1 for this. We need to use the drop 1 when something has 3 or more levels because that creates 2 or more indicators. So the reason we have to use drop 1 here is because day has 6 indicators. Does that make sense? And so I did the partial f on my own, which you don't have to do. You can use the drop 1 command with test equal f to do the partial f, and you can find out that day does not bring with it significant information. These other variables down here are bringing with them significant information. Humidity is definitely bringing with it significant information in explaining. So you could create a model with humidity and without humidity, but you don't have to because you can just do drop 1. Is that making sense, Kayla? Like the drop 1 does the partial f for you such that it creates a model with and without that variable. And then that p-value right there tells you if that variable brings with it new information. So we learned from this that day does not bring new information, workday does not bring new information, holiday does not, that does, that does, that does, that does. Does that make sense? So this is really good to have significance here. It's basically saying if you compare a model with and without these variables, not like all at one time, it's individually done. Yeah, you don't need to do it. This whole step, great answer right there, Kayla. This whole thing right here,
it doesn't matter.
We don't need to do that anymore. You just do drop one. So you can literally, you could create a much bigger model. Like I could go in here. Let me grab another data set. We'll grab survey 09. I could predict like somebody's height from all the variables and do data equals survey 9 and then height not found. Oh, it's called like EX2 height. Oh, is it called EX3? Oh, what is it called? Really? I hate that these ones are EX03. Wait, let's go with that. Is there no height? It's capital. I hate this data set. That's why survey 10's the best. And then we could go here to drop one on it, and it'll do each one. There you go. There's the drop one. And we could look at, we didn't do test equals F. So we have to do test equals F to get our p-values. And there's all the p-values on them to see if any variables are significant when they're removed from the model. So you can see here, this one's sitting location in class has with it three levels. So we have to use the drop one to see its significance. So other things like Peel's View and Obama had 2 levels, or actually, no, that had 3 levels, excuse me. I always forget it. Yeah, I know, right? Because it should just do it by default, in my opinion. I don't know why it doesn't. I was wrong about seating location. It actually has 4 things because it brings with it 3 indicators. Anything that is quantitative, like how much money you pay for a haircut, getting one tomorrow, is going to be quantitative. Awesome work. Okay, let's see if there's 2 more parts of this. We're going to do Leo's question here in a moment. We're going to check out Ashton's stuff. All else being equal, comparing days with identical values from other predictors, does it look like demand varies whether or not it's a rainy day or not? Is weather statistically significant? Justify your answer. And I'm pretty sure, I think I just overwrote my model. Is the weather statistically significant, Kayla? What are your thoughts right here? Is weather statistically significant? I'll let you answer it in the chat. And then how would you justify your answer? I think this one you've got, that's the same p-value. That 0.0348 is the same p-value you'd see up here for weather, because one indicator will have the same p-value whether it's dropped in or out. We have to use the partial F for categorical variables that have 3 or more levels because they bring with them 2 or more indicators. So when you have something with 3 or more levels, you have to use the partial F to see if the indicators they bring, the multiple indicators, not just the one like this one. Does that make sense? That's something we'll talk about a lot today, is that if something has 3 or more levels, you have to evaluate its significance by removing it completely from the model with a partial F and then seeing if it brings with it new information. But that's good stuff right there. Question E done. Good stuff. We'll head back over here. Leo's question, Ashton's coming right up. Okay, so let's take a look right here. Ashton, I'm going to take a quick look and give a quick spin. Let's take a look. Thank you, everybody. Leo's got a really good question on the Discord. Let me grab the last name. You're welcome, Kayla. Excellent work. There we go. Got up early today. Oh. Sometimes the graders are real particular. Let's see. Yep. Ashton, wherever you want to go. Ashton, I assume since you put Ashton. Ashton, I looked it up. Not saying anything. Ashton. Boom, boom. Boom, boom. Yeah, so take a look. Ashton, tell me if you see the confirmation. And not just that, but that. There you go. But tell me if you saw some... So, because I think you were doing what we were doing. That's what I'll say about that. I think you'll be happy. Well, I can't say anything. Can't say anything, but I did look. I think I can say I looked and made my executive decisions. That's the only thing I'll communicate. Well, thank you for asking. You're always welcome to ask. That sounds a lot like what we were saying. So I think executive decisions. And please always let everyone know. Just come in, ask your questions. As long as you're okay with me answering things like this on stream, I'll be more than happy to talk about it. And I can always answer via email or Discord if people prefer it that way. Like, I realize some people, it might be a lot for someone to come on here and be like, hey, Brian, can you... No, I appreciate that because, just jump on, just ask questions. You're welcome and excellent work. Keep it up. Do you have any advice for people in the chat or for class? I always ask it all the time. Like, we're getting Leo's question loaded up right here. I think the last part of this course is pretty challenging, but it's about as challenging as test 2. Like, it's more repetitive, which is kind of good because if you get down the last bit of material, you get it down and you know how to do it. My number one thing I tell people is come to class and practice and do the examples we do. I'll try to do as many problems as I can think of. So I'm always, it's tough. It's practice, 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 and practice some more. Don't let any questions shock you on the test. Don't let any question be like, what in the world? What's a confidence interval? I'd say, oh no. Oh no. Leo has a really good question. Leo's got a really tough one. I think I found it, Leo. Okay. Here we go. It is believed. Oh, found it. This is one of the toughest questions on here because it's algebra. Yeah, Kayla's right. Kayla, I was telling my fiance about how you said this, you can repeat it if you want, but you said, that you started coming to office hours and started to make a lot more sense. And I want everyone to know your story and your advice of you're like, hey, it was tough. Class was tough. Started coming to office hours. Started asking all those questions. Just ask Brian to repeat himself. Just be like, hey, I don't understand it. Repeat yourself. Slow down, Brian. Slow down. Leo jumps in here, says, I got a question. Love it. Doing Leo's question right here. So if you're watching this right now and you're afraid to ask a question, don't worry. We're just here to have a good time. Let's do some stats. Well, 1, it is believed. With chapter 13, it is believed. Let's do this. This is a tough one. Here we go. Now, I don't say lightly that these questions are tough because I've had instructors tell me, sometimes I've had an instructor or two, I don't know, I've been there. I've had somebody say, hey, Brian, help me solve these. And if you think you know who it is, you'd be wrong. Because I've had instructors, frankly, I've asked. I've said, how do we solve this? I've done it too. I've been there, and I've had instructors who taught as long as I have asked me, hey, Brian, how do we solve this? What's going on? And I've got these problems wrong. Watch me get this one wrong. It's one of the tough ones. It brings back memories of saying, wait, how do you solve this? How do you get this? So let's learn how to solve it. You ready? It is believed that as many as 20% of adults over 50 never graduate from high school. Leo knows what we're going to do right here in a moment. Leo, put it in the chat if you know what we're going to do. We wish to see if the percentages is the same among the 20 to 35 age group, 25 to 30. What sample size would allow us to increase our confidence level to 95% while reducing the margin error 2%? Notation, brother. We need
It doesn't matter.
a notation, brother. So I'll go ahead and do some notation here. Thank you, Leo, for submitting this question. It is believed, and so we're going to take this right here as an estimate of the truth right here of p hat. This question is a bit weird that it does this. There's an even harder one that is actually the one I was asked for. And I was asked about this 5 years ago. Maybe it was even 6 years ago. We changed the quizzes a while ago and added more questions. And an instructor said, how do you solve this one? It wasn't this, I think it was one similar. And I said, oh, you have to assume this. And they're like, how would anyone know that? And I'm like, I don't know. It took me a moment. I had to look up how to solve. I'm not saying all of them, but some of them are a little tricky. I'll say it. So don't worry. If you're here right now and you're practicing, you're learning how to mark that notation and get good at this. So it says, what sample size would allow us to increase our confidence level to 95% while reducing the margin of error to 2%? So there's a formula that's going to help us right here. There's a formula that we're going to need that's going to allow us to solve this. And we need the formula to make a what right now? We need the formula to make a what right now? We need the formula to make a what? What formula am I going to write down? Now we're going to use it here in a second. We need the formula to make a what right now? Think about it for a moment. This is, if you get this, you can probably solve it from here, but I'll solve the rest of it. We need a formula because it wants us to make a what? That's actually it, Leo. Great job, Leo. Let's throw out more 500 points. Yes, we can use that. I'm going to use a smaller component. Well, I'm going to use the full thing to start. Leo, that is correct. We are going to write the formula for the margin of error, but we are going to exactly margin of error. Kayla right there, even great work and great practice, Kayla. We're going to write the full formula. Great job, both of you right there. That is the answer. What we need is the margin of error for the confidence interval for the true proportion, because that's the chapter we're doing. We're doing the true proportion, and we want to figure out, what is the margin of error and the sample size needed. And so what we're actually solving for, we'll do another color right here. This is the blue portion right here, the margin of error. So it says that the margin of error is equal to 2%. And so that whole thing there is the margin of error. Does that make sense, Leo? Are you with me with this so far? Like, that is the margin of error. That is 2% right there. So that is the margin of error. That is 2% right there. Like, that is that. And from here, we have a bunch of other information. Like, we know what p hat is. We know what q hat is. And then the problem becomes I'll change the color here now. The problem becomes a solve for n sort of problem where it says what sample size would allow us. So now we're going to, awesome, Leo. Well, don't worry. And so p times q over n squared root. And this one's p hat times q hat over n squared root. Great job, Kayla, right there. So now we're going to take those values of the p hat and the q hat. And we'll look this up. We'll show how to get it again. Remember, use the exact value on this. If for some reason you're like a decimal off, just tell me. You probably use 2. If you don't have the number memorized, 1.96. This is how you would get 1.96. 1.96 is the z-score for a 95% confidence interval. We would tell you this on the test. So even we don't require you to memorize a z-score of 1.96, but the middle 95% of the curve shaded is not exactly 2. It's 1.96. Or 1.95996 if you want to get real particular. But there's just more decimals that we don't see in the background. So the z-score here is the amount of kind of standard deviations or standard errors in this case that we're going out. More standard deviations, wider intervals. Like that is where it's 3, 99.73. 68.26, I think is 1. There it is. And 95.449. No, wait. Yeah, it is. Not around to that. That's where it's, 95.45. Is that's 2. There it is. Get my numbers wrong. I used to know all of them pretty well, but now I'm getting rusty on my z-scores. But we usually say 68, 95, 99.7. So for all intents and purposes, if you're doing it in your head, that's basically 2, and that's what we use in 320 when we do the 2 standard errors. So Kayla's seen that, where we go out 2 standard errors, and we just take the estimate, and we say plus or minus 2 uncertainties. So when you're doing this right here, you're going to plug in your z-score, which is relative to your percent confidence. Your confidence level is controlled by the z-score. Higher z-score, more confidence, wider interval. And so let's go ahead and plug in some of the numbers right here. And so this will be, we should have kept the thing right there. That'll be 1.96 found by the applet, told to you on the test. And then the p times q over n square root, and we're solving for n. Now, I might not, my algebra is pretty bad. I might solve this a different way. Sure, we can do it reverse. Algebra is cool like that. Okay, so there's the numbers. But a better way of doing this is to solve it for everybody. So if you're watching this, because I don't love algebra problems, is what we're trying to solve for, is we're trying to solve for n. So what we want to do is we just want to solve it algebraically. That up there, if we solve that and reduce it, it'll solve for n. But we have here z-score times p hat q hat over n. So we would divide both sides by the z-score. And let's go right here, divide by z-score. There we go right there. Now we need to square both sides. So we square both sides. There's the squaring of both sides. Now there's a super cool trick you can do. You may not know this, but you can actually flip equations. So we can take this and flip it, pop it, twist it, do all those things. Do not miss. I know, right? Like I said, this is more of an annoying problem. And we get n on top right here. And then we're just going to take, oh, really? We're going to take that and just multiply both sides. So I guess we could write the last version down here of z over me, the margin of error, squared p hat q hat equals n. And that's the answer. So now it just comes down to plugging in the numbers, which we ran out of room. So we'll do it up here on the top. The z was 1.96, divide by margin of error 0.02, square that quantity, and then times 0.2 times 0.8, and that will be our answer right there. Yeah, it's just an algebra problem, which is not my favorite. I like interpretation stuff, but it's just an algebra. But like I said, watch me get it wrong. You never know. And it might say round up or something, so let's watch as we put in the answer. They are tricky. Round up to the nearest integer, so watch out. You have to round up no matter what. So if it was this, you would still round up. Carry your decimals. Woo! What happened if we rounded down? Woo! Getting scared right there. What happens if we just guess at it? Woo! It's got a nice boundary on that question. So it's a little bit nice on how you carry your decimals. I would still round up like it says. You're welcome, Leo. Should we do there's a harder version of this. This one I think is the harder version. This is the one, no joke, 5 or 6 years ago, an educator said, how do you do this? I said, oh, I literally, and I'm not joking, this is probably the hardest one. So let's do it here next. Okay, time for one of the hardest problems, and I do mean this. When I say people have asked me how to solve a few problems, and I've had to take a moment myself, I mean it. So Stats 1, Chapter 13, editors preparing. So let's do this. Okay, so this problem right here is just like that last problem we solved. It's going to boil down to notation. It is literally a direct copy of the last problem, but it doesn't tell you something. And that's where my friend, good friend, I miss them. I'm going to see them back in Knoxville. I'm going to swing by their house. No, I don't want to say who it was, but it's someone I work with who's super special, yeah, they're really nice. And they're like, how in the world, what? Daddy? I was like, let me show you. Because I was like, I had to look it up too. It's weird because when you look at this, what are we missing here, Leo? What are we missing? We have, if Leo, you're still watching, we got here a margin of error of this, and then we got a confidence of this. So this is telling me my ME right here. And this is telling me my Z right here. And then the question becomes, what are we missing? Because let's solve it the previous way. If you remember, we did P hat plus or, oh, Leo sees it. So Leo, let's see if you can solve it. Let's see if you know what we would do. And they were like, really? And I was like, yeah, really. What would you assume without any knowledge about P hat? So Leo, you are correct. We're missing the P hat. We have the other information. This problem is literally a direct solve like the other one. That's the margin of error because it's everything after the plus or minus. It wants to know the sample size again. You got this, Leo. This is worth 1,000 points, Leo. Take a stab at it. It wants to know that. We don't know. So what do you think we should do? Because we don't know them. It sounds ridiculous. And the answer is like, really? And it's like, yeah, really. What do you think? So right now, you got this. What do you say? Kayla's trying to lead the way. We'll throw you points no matter what, Leo. Right now, it's like, what do we do here? We don't know those. We can do this the same way. If we know those, we can solve it the same way. I think I remember the equation. The equation to solve it is, we just solved this a moment ago. Check the previous problem. Z over ME. Oh, wait, so wait, just, you don't know it. So what's your guess? Like, what would be, don't go too extreme. Here, Leo, think of this. Don't go too far in any direction, but what's your guess if you just have no idea? Like, I don't know, maybe this for both. I don't know, maybe that's just a good guess because I don't know where to go. You have no idea what to guess on it. Well, so we'll solve Z. Good answer right there. So Z is 1.96 again. So that, ooh, great answer, Leo. Leo, that's for some. I can't. There's some hints in the chat. Some 500 points. Some hints in the chat. So, oh man, I'll sleep one of these days. And this, so if you're wondering what we're doing right here, please watch the previous question. I don't consider the work to solve this super important. Check the previous question where we went through and we solved this algebraically to show, so in the previous question, it's a very similar solve. And we go through here and we wrote the algebra out to solve it by resolving this, which we did right here also. So we took this, rather than solving it as is, we wrote it and reconfigured it. And you can watch me do that process of solving for n right here. So we've just written the format with it solved for n. Instead of it written this way right here up top, we've now re-expressed it in a solved for n fashion. Leo, any guesses? Don't worry if you don't have it. I'm throwing you those 500 points no matter what for 1,000 points total, Leo. And Kayla, great work. We'll throw like teamwork makes the dream work right there. Kayla's right. So since you have no, does that make sense, Leo? Since you have no real guess either way, it's like, well, 50%. So since we don't really know what p hat is, it's just like, well, I guess p hat is equal to 50%. And q hat is equal to 50%. I mean, we don't know which way it goes. Does that make sense? You just say, well, I guess 50-50. Does that make, since we don't, I mean, why should it be higher? It's like, I guess they're equal to each other. I mean, why should p hat be higher, q hat be higher? It's a weird problem in that way. Yeah. That Kayla remembers it because it's kind of it's a mean question. And I'm glad we're doing it right here. And that's why, like I said, I've had people ask me about this because I was like, well, you just have to assume. So you assume, which actually, theoretically speaking, this will create the widest interval. If you actually use a p hat of 1 and a q hat of 0, it breaks the at least 10 rule because p hat or q hat times n would be 0 times something. And then you would not get at least 10. So the interval can't be created properly. So you have going the 50-50 route creates a symmetric sort of interval and the largest possible margin of error. And it passes conditions most likely. So it's like decent theory. Not a big fan of it. Yeah, so 50-50. Exactly. Does that make sense, Leo? Not a good test question. What we should know for this notation or for this question is the notation. Yep. And then we just solve right here. We're just going to plug in the numbers of 1.96 because 95% confidence z-score. Margin of error is 5%. And 50-50. It's going to be like an 800 maybe. I guess my guess is 800. Let's see how close I can get to these from having solved a lot of these. 1.96 divided by 0.05 square. Half of that. Ooh, it's going to be closer to... Oh, man. There we go. That's a guy right there. Good stuff right there. We had some big points. Yes, from officers. Have some fun. So we should have it. Watch me get it wrong, as per usual. Round up to the nearest integer. No. Thank you. It's really nice. I'm glad these ones are not so mean about it. You should round up. Please do what it says. Don't be like me. It gave it to me. We put the streak on the line to see if it would put it the correct answer. Leo, are there any other ones you're wondering about? Done with class, just relaxing. Any other questions you're wondering about? What are you thinking? Kayla, do you want to go back and do some 320? Let me know. Just kind of jumping around between topics right here and practicing. Yeah, 2B and 2C, you bet. Let's hop back to the main screen. Leo, drop some questions if you have them. Head back to the main screen. Okay, 2B and 2C. I'll get those loaded up right here. 2B and 2C. Oh, hold on, new version of this. We had pizza last night. It was so good. I have been making my own homemade garlic butter with pepper in it. Oh my gosh. That's stuff. Don't do it. Don't make garlic butter. You'll want garlic butter every day. It's too good. Kayla, your thoughts on garlic? People are either pro or against garlic. I am very pro garlic. Garlic, mushrooms, onions, but olives I am not. Olives, no. No olives. Here we go, found the assignment. Olives are bad. Getting very controversial today. Garlic mayo on burgers. That sounds awesome, Kayla. 100 points right there. More points on these crazy office hours. You can tell the tour owners I just finished a test. Office hours squad? Yeah. Nice. The two owners just finished. Oh, yeah. Yeah, they did just finish the test. You can definitely tell. Awesome. We'll do some 2B and 2C right here. BAS. Let me take the timestamp. 49:58. BAS 320. Assignment 9. 2B and 2C. Here we go. Let's head over to the main screen. Pineapple and black. Oh gosh, pineapple and black olive pizza. Oof. Change out the olives for ham, and that's good. Pineapple and ham's amazing. So 2B and 2C. We're down. Where's 2 at? There's too many 1s. Okay, so here's 2. So we've got a model to start with, and basically somebody's ran a what on their model here, Kayla, it looks like. What does it look like somebody's run on their model? Maybe we'll look at some fun stuff at the end here. What does it look like somebody's ran inside of R to get this? Oh, you're fine. Well, we're just starting on this. They've ran a summary. Yep. So somebody's ran a summary right here. We've got the estimates of coefficients. We've got the standard errors, which are the uncertainties. We could go 2 standard errors and build a 95% confidence interval for any of these estimates. We've got the t-value, and we've got the p-value right here. Yeah, things look accurate. Good. I was like, great changes. And so we're trying to predict, in marketing analytics, the relationship between sales of a product and the amount of money spent on advertisement is often studied. What follows is output of a model's prediction: sales, $1,000 based on the amount of advertising, and thousands of dollars, the room in which the product will be placed, and the size of the product. So think about this. You're saying we are going to sell to somebody a Ninja blender. So what is the size of the Ninja blender, and where does it go? We're going to sell to somebody a Ninja blender. So what would that be? And then we're going to take out $5,000 in ads in it. And then this is our, how much we expect to make, I believe, right? So we are predicting right here the sales, which is how much we're going to sell of that product. So think about this. We're taking out $5,000 in ads. So we'd put a 5 right here. Boop. So we're selling a Ninja blender. So what would we put for this right here? We're selling a Ninja blender. Does that go in the kitchen? Or the bedroom or the office? You put a Ninja blender in your office, I guess. I'll go bring mine over here. Nice job, Leo. 100 points. Kitchen. So what should I put when I'm solving this? If I were to solve this out mathematically here, which I'm just kind of inputting values in, if I'm going to solve this out mathematically for room kitchen, I would put a what? Because Ninja blender goes in the kitchen. Great job, Leo. I put a what right here because Ninja blender goes in kitchen. So I'm told. Boop. I'm just kind of solving it or talking about what would go in here. Like I'm making kind of a prediction with this model. I'm saying that there was, I'm like pretending that, I'll write it. This is a pretend question right here. Pretend that we are selling a product that has $5,000 in ads, and it's a Ninja blender. So if you were to solve this out right here, when you're multiplying and putting things together like this, plus this, times this, plus this, times this, plus this, times this. Yeah, no, I just made up a question. You would put in that the ads are 5,000. You'd put in the room is kitchen. You'd put in it's not the office. And you'd put in that it's a small item. Does that make sense? So we could go through here and figure this out by adding these up right here and multiplying. Now, there's a lot of extra output, but does that kind of make sense what you would do if you were to plug in values and start solving out this model? Like, basically, we should understand what this data is. Exactly. Well, Oh, but also 1 goes in for small because size is a second categorical variable. So the reason we can have a kitchen 1 right here is because that's for room, and size has 2 levels. Does that make sense? So good job, Leo. Excellent. And see you in class tomorrow. So we can put in 1 for size. But let me ask you this, Kayla. Imagine we're selling a bed. So very obvious what a bed is. Like, exactly, Kayla. You maybe get where I'm going with that. If we're selling a bed and we're taking out $10,000 in ads, then what would go for room kitchen? So we're selling a bed now. We're saying, okay, we're going to take out $10,000 in ads for our company to sell beds to people. Room kitchen would become a what now when we use the model as a predictive model? So we're taking $10,000 in ads out on this item, which ads is a quantitative variable. Exactly, because it's not kitchen. It's not office. And here, we're going to make these further over here. It's not kitchen. It's not office. And then it's a large item. Like beds are larger items. Hence, beds go in bedroom. And so because because bedroom's reference. Exactly. So it's not kitchen. It's not office. And it's not small. And large is... Kayla, 100 points. That's exactly it. And that's where I was going with this to understand kind of what it's doing right here and how we'd use this predictive model. That's it. Probably a lot of the answers are just going to flow from this now because if we think about what the intercept is, we kind of just talked about the intercept. I might not want to say, but we kind of just talked about it, right, Kayla? The intercept. Now, more specifically, ads would be what for the intercept? Because the intercept is this. I mean, I'm kind of writing the intercept right here. So you have to think about what the intercept would mean logically speaking. The intercept is the predicted value for things, blah, 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 blah. I don't want to say it verbatim. I don't want someone to copy it too much. But the intercept, But then it's not that, and I think you know, it's not that room kitchen is 0. It's more specifically that something at the intercept is the predicted average price of things that have $0 of ads taken out that are products for the where. And then there's another thing you should say too, but for products for the where, because it's not room kitchen, it's not room office. You could say that. It wouldn't be technically wrong, but I'd preferably people say for products that are sold for the where if we're doing the value of the intercept. The value of the intercept would be items, the predicted average selling price of products that are have 0 ads taken out and are in room what? And then there's another thing you should say. I haven't said the whole thing here. So the value of the intercept, because interpret the coefficient. Oh, we're interpreting coefficient ads. Gosh, I blinked. I thought that said intercept. I was talking about the intercept, so it doesn't even say that. It's when all the x's are equal to 0. So the value of the intercept is the predicted selling price. It's not the question, so I won't say it here. The value of the intercept would be the predicted selling price of products that have no ads for them and are bedroom products that are large. Now, the interpretation of the coefficient of ads, I don't want to say that too much. I don't want to give away all the answers. But we need to start out with 2 products. Does that make sense? And then when you do your interpretation, you must ask yourself, is X quantitative or categorical? If it's quantitative, you'll say things like 2 products, but we have to add in something else that are what? So we say 2 blanks. Then we have to add in for multiple regression that are what? So we're kind of just talking through this a little bit here. So 2 blanks, then it's a multiple regression. So we have to say that are this. 2 blanks, 2 products. What would we add in after this? I'm on top chat this whole time. Otherwise identical. Yep, 2 products. Otherwise identical. But they differ in X by 1 unit. The product with the higher X is expected to have the blanker Y. The one, blanker, higher. Now be careful, use your context. This really comes down to practice, and I don't want to quite give this away. This is a little bit of components to put this together right here, so don't put in the chat yet, Kel, because I want people to try to think through and figure this out. But we basically have the components. Now this is if it's quantitative. If it is quantitative, we'll go this path. And think is ads quantitative, like ads in thousands of dollars. Is that quantitative, like an amount? If it's categorical, it's very similar. And we should put if multiple. If we're doing a categorical, which I think is coming up here next, two blanks that are otherwise identical, but one is indicator and one is reference. The one with the one that is indicator is expected to have the so we should give the values too. Like, to talk about this right here, we can do it with this output and not answer the questions directly. So these are 2 days that we are selling bikes. Does that make sense? Screenshot. It's not the... I like it, but we've done better. It's a decent screenshot. Like, I kind of like it. That's why I'm going to do some interpretations right here. Always try saying them out loud. Try writing them down. I don't want to give it away fully, and I want to like people to think through what they're saying and does it make sense. Like right here, let's look at day Saturday. Is day Saturday quantitative or categorical? And that's the first question to ask yourself. Just put C or Q in the chat. I'm going to interpret this one using kind of the format we got right here. So is it quantitative or is it categorical? Is day Saturday quantitative or categorical? So it's categorical, exactly. So we're going to have to compare it to its reference level, which is Friday, which is the first alphabetical. So 2 days where we are selling bikes that are otherwise identical, where one day is a Friday and one day is a Saturday. The day that is a Saturday is expected to have sales that is 91 less in demand, 91 less bikes demanded. So does that make sense? And I'll repeat it. 2 days where we are selling bikes that are otherwise identical, where one day is a Friday and the other day is a Saturday. The day, good to see you, Troy. The day that is a Saturday is expected to have bike demand that is 91 lower than the Friday. So just think about how you're communicating it. Makes perfect sense. Exactly. It's like, everything else the same. Friday generally has lower demand than Saturday by 91 bikes. But make sure you're saying 2 days that are always identical. It's not like we can't change it to being a Saturday or Friday. It's like comparing our general Fridays to general Saturdays. We would expect the Fridays and Saturdays to have this difference right here on two otherwise identical Fridays and Saturdays. A lot of ways to say it, but we try to go for a general format. But now let's go down here to temp. So this one right here is the coefficient of temp, which is quantitative. And with quantitative, we'd want to say the following. 2 days where we are selling bikes that are otherwise identical, like everything else the same about them, is a busy day. 2 days where we're selling bikes where they're otherwise identical, but they differ in their temperature by 1 degree. The day where the temperature is higher, we expect the demand to be 126.793 higher. So 2 days that are otherwise identical, but differ in their temperature by 1 degree. The day where the temperature is higher, we expect the demand to be 126.793 bikes higher on average. A little on average on there. It's expected, so it's saying like not like it is. Never say will or is. It is going to be higher or will be higher. We expect is a good way to say on average, because it's expected value, like the mean is the expected. So I think this kind of covers this one. What is the implicit regression equation? So to write implicit regression equations, we need to first start doing. So I won't write the full thing. We'll write what we have. Can I get the? Let me get the output over here. So to write an implicit regression equation, we do the classic of this plus this times this plus this. So you go here and you first write the what equation. So Caleb, if we're going to write an implicit regression equation, what's the best place to start? It's called the something all equation. It's like something like I'm like charadesing it like a mountain, and you we call it the what equation. Like when before we solve for anything, we write the what equation usually. And we've been doing it for a lot of these problems right here. Not the catch. You're going like overall over a mountain, right? Overall equation. Exactly. Great job, Kayla, right there. So the overall equation. And we are predicting sales right here. So sales is equal to the intercept. And we could literally just start taking these and plugging them in almost as is. Sure. I don't, maybe fix that later. Ooh, I don't want to do that. We put the coefficient first, mathematically speaking. I'm not a, no. Not that I don't have spell ads, but we usually put the coefficient before the variable name. And so there we go. So we're writing the overall regression equation right here, and check out, I might not solve this fully. Well, it's going to be a minus. So we're just making it look nice and pretty right there. Formatting, it doesn't change the bottom, but I do like it to look very nice. There we go. And there's that. Oh, we didn't grab the variable name. You bot talking away in the chat. Such a talkative bot. And there it is. And from here, yeah, exactly. That's what I like to see. Now you're like, okay, now we just need to plug in, what is it? We need to plug in zeros or ones, and we won't plug in anything for adds because adds is the line we're solving for. So these are going to just change the what value. When you plug in zeros and ones here, Kayla, like if I plug in a bunch of zeros, it's literally, well, this one didn't, but the only thing that right now without an interaction that indicator variables would change would be the what. Like if this was, instead of a large item, it was a small item, it would be, this would be the answer to the question. The only thing that these models will change without interactions, key for the learning objectives, the only thing that these models change without interactions right here due to indicators just being zeros or ones, they're constant changes. And we don't have one loaded up that would show. Intercepts, yeah, without interactions. Oh, no, intercepts. If they do have interactions, they will change the slopes. Without interactions, they won't change the slope. So if we predict here demand tilde temp and humidity, there it is. Data equals homework 9. Homework 9. Oh, what'd I do? What? I've lost my mind. What is... Oh, if I not... Wait. LM demand data equals... What is going on? Let me remove stuff. What have I done, Kayla? Object is not a matrix. What am I doing? Kayla, do you see it? 500 points. Brian can't code today. I'll bring it up here so we can see it. No, not the comma. Not the comma. It's not the comma. But you'll see it. 500 points here. It's not the comma. There's an extra something. I don't know what I was thinking. Oh, no, sorry. Yeah, exactly. Yep. Tilde. I don't know why I did a second tilde. Who knows? The world may never know. Might try to make the 3D plot here in a moment. So you see right here, we have the different lines. If we add in a interaction, they can have different slopes. So this is with no interaction. This is with interactions. No interactions, with interactions. No interactions, with interactions. And there was a really cool package. ggplots for regression. I'm trying to remember the name of the package. People are asking here, but or Plotly for regression. So let's see. Here it is, MI. Here's the page. And this is too much work. It's way too much work. Someone made a function for this. I know they did. I saw it. And here's the mapping of it. So let me grab this and try it. I want to see if this works to kind of end off. And let me know if you have questions. We're going to try something really cool right here, because I've been wondering. Maybe I'll show at the start of class. So let's see right here. They're doing two quantitative x's. So let's do height and weight Let's just use their data. See if it works. Well, this is how I broke my R last time. Let's break it this time. It did this. Cannot find function fit. What is going on? We're going to break it again. Shouldn't do this. Failed to load tiny models. Weird. Don't save. Don't break. But let me know. Put on the music right here. We'll see if we can get this to work. I really want to see the 3D plot. Okay, you ready? Boom, boom, boom. Okay. Just warnings. Oh, no, it did it again. Tidy models is not working. And that's the problem. I think I updated all my packages. It's not going to make because it doesn't have the figure. It's in the model. Packages. Updates. Select all. Install updates. Sure, restart our... Yeah, let's see what it does. Maybe I should have read that. Updating the packages. I thought I updated them last time. XG Boost is a good package. So many packages updating. Up. Update. Select all. Install updates. We'll restart here in a second again. Install from source. Okay, we're getting somewhere. Maybe this will fix issues. Update those packages. Lazy loading, we love it. If you have questions, let me know. We're just kind of seeing if we can get this to work and do some cool graphics inside R. Might show these towards the end of class. 2 hours later. This might work, Kayla. Who knows? This is Alex and I broke the code in the last one, in the last class. Was the last class? I think it was the last class. Oh, I guess last class was a week ago, wasn't it? Oh my gosh. Last class was a week ago. What are we doing? What is this doing? Ah! You okay, R? You okay? It might work, it might not work. We'll find out. Preparing for lazy loading. What are you cooking for dinner? What's for dinner tonight? What is for dinner tonight? I think I'm hungry. I think that's the issue. I'm tired today. I got up early. Got up early today. Got a lot of work done. Had some meetings, multiple meetings. Got to talk to Charlie. A lot of meetings today. A lot of good stuff. A lot of emails. Big week. Getting prepared. Haircut tomorrow. Eye appointments. Fun stuff. Hot dogs. Had chili cook. Ooh, that's good stuff in the crock pot right there. Some good simmered chili. Well, the kids are lucky there. I like to take the hot dog and dip it in the chili to use it like a scoop. And that way you can get like your proportion out. You don't got to worry about like the chili just going everywhere while you're eating the hot dog. You just be like, okay, I got my cup of chili. Take my hot dog, dip the hot dog, eat the hot dog, dip the hot dog, eat the hot dog. And you don't have chili going everywhere. That's the way I do it. A bit crazy though. So, but chili dogs are awesome. Sonic the Hedgehog agrees. So, I don't eat hot dogs. It's just for the kids. Hot dogs are good. Like everyone like talks about. You get some kielbasa or something. Some like that's some adult hot dogs right there. Chili. Oh, chili and cornbread. That's some good stuff too. I'm not the biggest cornbread fan. Chelsea loves some cornbread. Chelsea's. I wonder if it's a southern thing because I'm not. You know, I'm the New Yorker. I wonder if it's a southern thing. Man, this is taking a while to load. So, I don't know. Cornbread. It is, yeah. Like, what do you love most about cornbread? Like, I mean, it's good. Like, I'm not saying cornbread's bad, but if I had to pick, like, of my top side dishes, my husband eats it with milk, like Oreos. Wow. Yeah, it's like not that cornbread's bad. And I've had good cornbread. I've been to good restaurants, good cornbread. You put some butter on it, it's really good. Like, I'm just liking some butter. Saw my garlic butter earlier. Like, What is the appeal of cornbread? It's good. I give cornbread just a 5 or 6. But if you put like some garlic mashed potatoes on the table, boop, boop. You put some like Béarnaise mushrooms or something like that, or you put some like garlic bread. I'll grab 3 pieces of garlic bread before I grab a piece of cornbread. It's bread. Some good rolls. I love garlic bread. Yeah, garlic bread I'll grab before cornbread. I don't think cornbread's bad. I don't know. Garlic cornbread? Yeah, we should try that. That's a good idea. I would try that. I would try garlic cornbread. I know it's kind of like me. There's a little wonder about it. I watched a thing like they were cooking grilled cheese, and it was Bobby Flay and someone else cooking grilled cheese, and they were like, "This is my grilled cheese with tomato." And they're like, "Who could make the best grilled cheese?" And he's like, "I'm using Gruyere and Fordenberg, and I'm putting ham on it and tomatoes." I'm like, "That's a sandwich. It's not a grill. I mean, a grilled cheese is a sandwich, but you've left the realm of grilled cheese when it's not. I think a grilled cheese can only be bread, cheese, and spices. If someone can identify components in it, like, you can put garlic in it, you can put pepper. Oh yeah, Kraft slice. That's just classic. You can. That's why it's so easy to win on grilled cheese. Is you just grab like 2 Kraft slices. You get that thing nice and pressed, so you get that just pull the grilled cheese. Well, I just want a grilled cheese now. You can make some really good grilled cheese pretty easily with tomato soup. Oof. See, there you go. You see, some things are just so good and so simple. What is it doing? Namespace CLI. Oh, so the CLI is mad. Well, CLI is the problem. It's saying the CLI is not updated, and it says 3.2 is available. So this is the problem right now. It's mad about this. My husband eats it that way too. Oh yeah, grilled cheese sticks. That's awesome. Oh, dunk it in like Dunkaroos or something. Hey, we're all just big kids at heart, We just all just want to have some fun and relax and have some grilled cheese. That's a nice dinner. It's good stuff. Error install packages. Is it finally updating? Why will you not update package? So, oh yeah. Shout out to your husband. That is a good idea right there. I cannot get this package to update, and that is the issue. CLI. So we're going to try installing it. Just straight reinstall it. CLI, I don't even know what CLI is. Oh, it's doing it for me, and it just won't work. Oh my gosh. What is it doing? What says it? What says access denied? It might be a permissions issue. So I'm going to do here, I'm going to run RStudio as admin. I can show this right here. I'm going to run as admin. And so it says, do you really want to run this as admin? I say, yes, I do. Why do you think I clicked that? I say, yes, I do want to run as admin. I just restarted. Let's see what it does. CLI access denied installing package R. Okay. CLI access denied install R package. Okay. Here we go. Run RStudio as admin. That's what I did. Under the package tab, click install library, open. Okay. Under packages, go to the install. They've got their blank. Under the packages tab, click install. Install to library. Wait, what? Oh, I've got that. Oh, okay. Click the program file. Oh, that's... Okay, let's see if this works. Hey! Points for Brian. Okay, so that looks like it worked. Failed load names CLI. What is CLI doing? What are you doing, CLI? Now other things need updating? What is going on? Select all. Install updates. What is this computer's haunted? What is going on, Kayla? Why can I not get CLI 3.2? Let's see here. What is going on? Okay. Okay, let's retry. Let's reset. Unable to install. Yeah, other people are having problems. Okay, so they're saying update R. Oh, this will be interesting. What version of R do I have? Why not? Let's update. I have 4.1.2, and they're older than me. Why not update R before class? Oh, 4.1.3, really? How recently did it come out? I don't even know when it came out. March 10th. Is that really the issue? Really the issue here? Quick question. Take a look right here. I'm going to install it already. When talking polynomials, we want M to be... I'm installing R. Let me close out the bills. English. Yes. We want M to be 1 or 2. 1 is a line right and 2 is a polynomial curve, whatever it's called. That's correct. Well, you don't... It's not that you want... when you're looking at the polynomial model... you want the lowest possible polynomial order within 0.05 of the best R-squared adjusted. Does that make sense, Kayla? I can show you some examples here in a moment. Thank you for bearing with me as I try to get this working. It's just driving me crazy that it's not working. Quiet office hours, so Brian just starts devolving into madness right here. But the first model we think as the best model that is the least complex would be the linear model. And then you fit a parabola, exactly the 3 steps. So you find the highest R-squared adjusted, you subtract 0.005, and then you find the model that is best within 0.005 starting from the start. So if this didn't work, I just reinstalled R. So now we should have the newest version of R Studio. We'll just let it cause all different problems now. Probably don't have my packages. So... I am on 4.3 now. 4.1.3. One push-up. That's the nickname of this R Studio. We probably don't have our libraries. We have our libraries? What? Usually don't keep the libraries. Oh, and it's still... I'm just going to lose my mind. Okay, one is one is a line, and you can see right here if we go to... I might have run into the problems I run into... if we do like HP weight data equals empty cars and we visualize, because I don't have red class loaded up. So visualizing our model right here, we get the line. And if we go to choose order, I'll just bear so you can see it. Thank you, Kayla. Good questions right here. Choose order, the linear model is the first order. So you can even break it down a little bit further by going to max order and going to like 2 and only compare those models. No, you're fine. This is what I'm here for, Kayla. This is what I want you to ask, because which model should we pick from this right here? The answer is pretty clear. If you were presented with this information on the test, which model would you pick from this list of models? This is a great question, which I hope people have the skill set for. If you get it right, you know it. And if you get it wrong, it's just good practice. So first, second, third, fourth, fifth, sixth, what model is the correct model according to the 0.005 standard? And I'll go through the steps here again. So this is a really good practice. Here, I'm going to rewind. Good. Is that your final choice? You're on the right track. So let's say BS320, picking polynomial models. So you said go right here and subtract 0.005 from it. Step 1. Oh, find the best. You found the best. You subtract to 0.005. And so now what is your final choice? So what would be your final choice right here? And great practice. That's it. You're right, Kayla. Because then you would say, this doesn't meet it, this doesn't meet it, this does, and then you don't go any higher. So that's exactly it, Kayla. So you would kind of want to use, the reason we check the first one is because it's the simplest, and it's like, why go to higher polynomial degrees if we don't have to? So you're doing the exact right thing right there, is you find the highest R squared adjusted. That's step one. Step two is subtract 0.005. And then the third step is to check the first, check the second. Like you just go through until you meet one that meets the standard. And this meets the standard, so that is the model we will use. That's excellent. And for all my work, Kayla, it looks like I'm not going to get anything achieved on the other thing here, because for some reason it doesn't want to load. Like I've been reloading R and reinstalling R. I literally just reinstalled R. I didn't lose my package, which is interesting. Might just like completely reinstall. Tidyverse loads, but Tidy Models doesn't load. And it says that CLI needs updating. It's this one package. Which was updated, I don't know when. Break change. Well, I don't need that. So all we need to do is update this one package. I'm going to try to do the update thing again, where it's said to go. It's said to go to my install, CLI, install. It says permissions. I loaded it as admin. I have no clue. Run as admin. What is going on? I run as admin. Install. CLI. It says I will not install. Should I not get this package? Permissions denied. Points, Marjorie, good to see you here. If you have any questions, let me know. We're about to end here in a moment. We are trying our darndest to get this installed. It says CLI successfully unpacked. So it says CLI is installed, but it's 3.1. Marjorie, we've failed. We did not get CLI updated. We just cannot update it. And it's stopping us from making a really cool graphic. Let me delete a package. Delete a package from R. How can I uninstall a package? Yes. That might have been a really bad idea. It says it installed. I don't see it. We have restarted R 1,000 times. See you in class, Kayla. Oh, hopefully I didn't break anything. No. Oh. Is it going to happen? Will it happen? Okay. We've done it. We just made 3D regression. There it is. There's a 3D model of our points with the 3D grid for the model. And with seconds, well, we'll need to send out the announcement, but that's got it. We have made a 3D regression. That's good. Well, we achieved the goal. So we'll post the announcement for class and we'll get to show this. I'm very excited. I really was just like, We have to get this. This has to happen. And so let me get the class video. And there it is right there. Class in 11 minutes. That's got it. Well, until then, we'll be back here in just a little bit. Bye for now, everyone. Bye.